Alright, in this video I'm going to do a couple examples of solving some quadratic equations by factoring. And in our first example here we've got x squared minus 9x plus 14 equals 0. And again, the basic idea is we're trying to factor first off. So one thing that's important is you want your one side of the equation to be equal to 0. So notice we have that in our first example. We don't have that in our second example, so that's actually something that we'll have to do first in that problem. But in this one it is set equal to 0, so to me that's good. And again, since the coefficient on the x squared is a 1, if it factors at least, nicely with whole numbers, I think to get the x squared I would need an x and an x. And then again, I'm looking for two numbers that multiply to positive 14 but add up to negative 9. So, I'm thinking about factors of 14 in my head. So, 1 and 14, well, I don't see how I can, add or subtract or do anything with that to get a negative 9. So I don't think that pair is going to work. Well, 2 and 7, I can multiply those together to get positive 14. So, and hey, 2 and 7, if I add those, right now I would get positive 9, but if we make them both negative, so negative 2 and negative 7, those still multiply to positive 14, but now they'll give us the correct sign in the middle. So the way I think about it, if the number is positive, they either have to be both positive or both negative. Whatever the sign on the middle is, if it's negative, that's what they'll both have to be. Okay, so we use negative 2 and negative 7 equals 0. Okay, so the point of having this factored is now, again, you're trying to, we want to figure out some value for x, so if we plug it into the first set, and then we plug it into the second set, when we multiply those two resulting numbers, we want to get 0 out. But if you multiply two numbers and get 0 out, it has to be true that at least one of those two numbers is 0. Not that x is 0, but at the end of the day, when you do the arithmetic, you have to get 0 inside the parentheses. So what that tells me to do is, it says, well, really we either want to make x minus 2 equal to 0. We want that to work out and be 0. Or we'd have to take what's in the second set of parentheses, x minus 7, and set that equal to 0. So this is the idea. You factor, you take each set of parentheses, set it equal to 0, and then try to solve that equation. So in the first case, we can just add 2 to both sides. We'll get x equals positive 2. We can add 7 to both sides on the second one and get x equals 7. And now we have our two solutions to this quadratic equation. Again, a quadratic equation can have exactly two solutions, or it can have exactly one solution, or it can have no solutions at all. I think both of my examples have two solutions. So, alright, 2x squared minus 5x equals 3. So, again, the first thing we're going to have to do is make one side equal to 0. A big common mistake, so this is something you don't want to do. A common mistake is people will say, oh, well, they'll just go ahead and start factoring. And they'll say, hey, there's an x, present in both of these terms, so let's factor the x out. And then we have, I guess it would be 2x minus 5. If you distribute that, you'll get 2x squared minus 5x equals 3. And then they'll take each little part and say, well, either x has to equal 3 or 2x minus 5 has to equal 3. And then they'll solve this for x. They'll add 5 and get 2x equals 8 and divide by 2 and get x equals 4. And that is very bad, because what you're saying now is you're saying if you have some number multiplied by another number, by making this statement you're saying, well, either the first set of parentheses has to be the number 3, or at the end of doing the arithmetic, what's in the second set of parentheses has to equal 3. And again, that's just not true. You can certainly multiply two numbers together where neither of them is 3, but at the end you do get 3 as the answer. So that just, if you think about it, this at all doesn't make any sense to do, okay? again, when it's equal to 0, to me it makes perfect sense to be able to break them down into these two individual equations. So I think that's something kind of important to think about, because again, then you're not memorizing some arbitrary procedure. You're understanding it at that point, why it is what it is. Okay, so in the first example, again, we want to make one side equal to 0, so I'm simply going to subtract 3 from both sides. We'll get 2x squared minus 5x minus 3 equals 0. And now to me this is a little tedious, because this coefficient of a 2 in front of the x squared, we have to be more careful when we factor. I think this is one I could almost do by trial and error, though. You could always do factoring by grouping, but I'm going to just try to trial and error it. So to me, the only way to get the 2x squared, at least using whole numbers, I definitely need an x and an x to get x squared. I'm going to have a 2 and a 1 to get the 2. Okay, fair enough. To get negative 3, I'm either going to have to use positive 1 and negative 3, or positive 3 and negative 1. Again, if I'm using whole numbers. And, in my head, I just start kind of playing with them. So, because again, I have a choice also of where they go. But I think if we put the minus 3 out here and the plus 1 inside, I think this is going to work, because we'll get our 2x squared. Notice 2x and negative 3 will give us our negative 6x. And then we'll get plus 1x, which will give us negative 5x. And then we still get our negative 3. So again, try factoring by grouping if you don't like this method. Certainly there's other ways to solve these equations as well, but again, we're talking about factoring here. So same idea. I take each little set of parentheses, set it equal to 0, and then I just solve those resulting linear equations in these cases. So I would subtract 1 from both sides on my first equation. So I would get 2x equals negative 1. And then I would divide both sides by 2. And I would get x equals negative 1/2 as one of my solutions. For the other one, I would simply add 3 and get x equals positive 3. And I've got my two solutions to that original quadratic equation.